Example 4. Calculate the integral of e to the power of 5x dx. Solution. If we let u equal 5x, then du equals 5 dx. So dx equals 1 over 5 du. Therefore, the integral of e to the power of 5x dx equals 1/5 the integral of e to the power u. Du equals 1 over 5 times e to the power u plus big C equals 1 over 5 e to the power of 5x plus big C. Note, with some experience, you might be able to evaluate integrals like those in examples 1 through 4 without going to the trouble of making an explicit substitution by recognizing the pattern in equation 3, where the integrand on the left side is the product of the derivative of an outer function and the derivative of the inner function. We could work example 1 as follows. The integral of x cubed cosine of x to the fourth plus 2, that's x to the fourth power plus 2 dx equals the integral of cosine open x to the fourth power plus 2 close times x cubed dx equals 1 over 4 times the integral of cosine open x to the fourth plus 2 close times open 4 times x to the third power close dx equals 1 over 4 the integral of cosine of x to the fourth power plus 2 times d over dx times open x to the fourth power plus 2 close dx equals 1 over 4 sine of open x to the fourth power plus 2 close plus big C. Similarly, the solution to example 4 could be written like this. The integral of e to the power of 5x dx equals 1 over 5 the integral of 5 times e to the power of 5x dx equals 1 over 5 the integral of d over dx open e to the power of 5x close dx equals 1 over 5 e to the power of 5x plus big C. The following example, however, is more complicated, and so an explicit substitution is advisable. Example 5. Find the integral of the square root of 1 plus x squared times x to the fifth power dx. Solution. An appropriate substitution becomes more obvious if we factor x to the fifth power as x to the fourth power times x. Let u equal 1 plus x squared, then du equals 2x dx. So x dx equals 1 over 2 du. Also, x to the second power equals u minus 1. So x to the fourth power equals open u minus 1 close to the second power colon the integral of the square root of 1 plus x squared times x to the fifth power dx equals the integral of the square root of 1 plus x squared times x to the fourth power times x dx equals the integral of square root of u times open u minus 1 closed to the second power times 1 half du equals 1 half the integral of the square root of u of open u squared minus 2u plus 1 closed du equals 1 over 2 times the integral of open u to the power 5 over 2 minus 2u to the power 3 over 2 plus u to the power 1 over 2 close du equals 1 half open 2 over 7 times u to the power 7 over 2 minus 2 times 2 over 5 times u to the power 5 over 2 plus 2 over 3 times u to the power 3 over 2 close plus big C equals 1 over 7 open 1 plus x squared close to the power 7 over 2 minus 2 over 5 open 1 plus x squared close to the power 5 over 2 plus 1/3 open 1 plus x squared close to the power 3 over 2 plus big C. Example 6. Calculate the integral of tangent x dx. Solution. First, we write tangent in terms of sine and cosine. The integral of tangent x dx is equal to the integral of sine x over cosine x dx. This suggests that we should substitute u equals cosine x, since then du equals negative sine x dx, and so sine x dx equals negative du. the integral of tangent x dx equals the integral of sine x over cosine x dx equals negative the integral of 1 over u du equals negative the natural log of the absolute value of u plus big C equals negative natural log of the absolute value of cosine x plus big C, since negative natural log of the absolute value of cosine x equals the natural log of the absolute value of the cosine x inverse equals the natural log of 1 over the absolute value of cosine x equals the natural log of the absolute value of secant x. The result of example 6 can be written as equation 5. The integral of tangent x dx is equal to the natural log of secant x plus big C.